So today's video is going to focus on non-specific defenses. So in your book, this is actually section 2 of chapter 12, if you would like to also do some reading and see the pictures and stuff that are in your book. So non-specific defenses are exactly that. They're not looking for a particular microbe or a particular pathogen that they're going to infect. They're just going to, in general, try to keep you healthy. Okay, and try to prevent you from getting any kind of infection. So our first kind of non-specific defense is our physical barriers, and they are exactly what that says. Okay, they are physically blocking the pathogens from being able to enter your body. For example, your skin. Right, if y'all remember when we did skin, right, it has all the layers. It provides a solid barrier that normally bacteria and any other pathogens, microbes, are unable to cross. As long as the skin is undamaged, they're unable to cross that barrier. If you also remember from our unit on skin also has hair that comes off of it, as well as does secretions like sweat and oil. And both of those appendages of the skin, they also help the skin prevent things from crossing into our body. Another type of physical barrier is a mucous membrane. So mucous membranes, they line our respiratory tracts, so nasal, throat, the digestive tract, and mucous membranes also line the urinary and reproductive tracts. Again, we talked about these earlier in the year. If you remember, mucous membranes were basically they line things that open to the outside, right? So that it prevents those membranes from drying out. So they have that layer of mucus on them. And so respiratory, digestive, urinary, reproductive, they all open to the outside. So the mucous membrane, the way it's built is it's going to contain that mucus secretion on the top, and there's also going to be cilia. Remember, cilia are these little hairs that you see on the top here. Okay, and so that mucus secretion is going to help trap the microorganisms, and then the cilia, remember the cilia wave, or they sweep things across the surface of the cell. So those cilia are going to help sweep the microbes that are trapped in that mucus secretion away from your body. They're going, for instance, in the like the respiratory tract, they'll sweep it up out of the throat, up out of the lungs, out of the trachea, so that it will then go down into, if you can swallow it, into the digestive system, and it can get broken down. Okay, so these are your physical barriers that are non-specific. We also have various cells and chemicals in our body that are also non-specific. So again, not looking for a particular pathogen here, just in general trying to protect you and keep you healthy. So our phagocytes, as a general rule, are non-specific. If you remember, we have a picture over here on the right of phagocytosis. Remember, phagocytosis is our cell eating. So these cells are usually larger, and they engulf, you can see it taking in the bacterium there. They engulf the foreign particle, and then they'll break it down. Okay? And so they'll basically digest it. So they'll take it in, their lysosomes will help break it down, okay? And so then it can no longer, harm you. So a couple of types of non-specific phagocytes that we have are neutrophils. We talked about neutrophils briefly with our white blood cells. Remember, this is our most common white blood cell. Neutrophils phagocytize bacteria as well as cellular debris, meaning the cell has been damaged, the cell is dead, and that's stuff you need to clean out, you need to get rid of. So the neutrophils will phagocytize bacteria and cellular debris. And then we also have monocytes. Monocytes are cells that will develop into macrophages. And macrophages are large phagocytes. And when we talk about specific immunity, macrophages will help kind of trigger that specific immunity and get that going. In addition to our phagocytes, we also have natural killer cells. Natural killer cells are going to, they're going to be lymphocytes, so white blood cells here, that are going to recognize and destroy abnormal body cells. So basically, if you have a cell that's infected by a virus, Okay, which means that cell is going to be working a little bit differently, looking a little bit differently. So infected by his virus, as well as cells that are becoming cancerous. Okay, so cancerous cells and viral infected cells will appear different, and so natural killer cells will try to take care of those for you. And they're going to do that by, one of the ways they're going to do that is by releasing perforins. Perforins are these proteins you can see in the picture here. Here's your perforin. Okay, so these perforins are these proteins that are going to poke a hole in the foreign cell membrane, in the infected cell membrane. So you can see here's my infected cell here. And so these perforins are poking a hole in it. And that hole is going to serve two purposes. Okay, one, it makes it more difficult for the infected cell to monitor what's going in and out of the cell. And two, it allows these enzymes here, these granzymes, that are going to activate the cells that will cause apoptosis. Remember, apoptosis is also called cell suicide. So these enzymes are inactive in the cell, but when these granzymes come in, they will activate those. And so basically that will kill your infected cell, whether it's cancer cell, a viral infected cell, which is helpful before it can spread. Another one of our non-specific defenses is the complement system. And the complement system has a variety of functions. So one of the functions is what's called opsonization. It's spelled for you right here. Right? So opsonization is going to be basically the marking of foreign cells, of cells that are infected, but the marking of these foreign cells with opsonins. And those opsonins help let those phagocytes know that it's foreign. So by putting these opsonins on it, you can see in this picture right here, okay, all these little red dots on here, those are those opsonins that have marked it. So the complement system did the opsonization, it did the marking, and that let your phagocytes know, hey, this guy's foreign, come get it, come take care of it. Okay, the complement system, you can see right here in the middle, it's a big like signaling cascade or pathway. So it's going to trigger a wide variety of responses are going to happen. So another one is that these mast cells are going to release histamine. Histamine is important in the inflammatory response. And the inflammatory response is actually a non-specific defense. So these mast cells will release histamine, which will trigger more inflammation. Okay? The complement system will also form what are called membrane attack complexes. And you can see this happening down here. Okay? These membrane attack complexes, kind of like that perforin channel we saw with the natural killer cells, these are basically create big giant holes in the cell membrane. So if I tear a hole in the cell membrane, that cell is going to die. It can no longer regulate, maintain homeostasis. So it can no longer regulate its internal environment from the external environment, and that will cause pretty quick cell death. So the complement system has two ways to activate it, what's called our classical pathway versus the alternative pathway. So the classical pathway is these complement proteins are there. Okay? They're circulating, okay? And what they do is they actually recognize antibodies that are bound to a target. Remember, antibodies are good, right? They're part of your body's defense system. We talked about these with blood types, right? So what happens is basically these complement proteins see your body already fighting something, and so they jump in to help. Okay? The alternative pathway is when we have these inactive complement proteins, and on their own, they recognize foreign material, and that kicks them on and activates them. Okay? So either basically they see your system already fighting something, and so that activates and turns them on, or they find the foreign material on their own. Okay, so next we have what are called our interferons. Interferons, just kind of like their name says, they interfere. Okay, so these are actually released by your cells that are already infected. So your cells that are infected by a virus, you can see it right there, okay, releasing these interferons. And so your cells that are already infected, basically what they're trying to do is trying to prevent other cells from getting infected. So these interferons will actually go and bind to healthy cells. And when they bind to healthy cells, they can help slow down protein synthesis. And if y'all remember from viruses, right, that viruses basically have to hijack, you remember they need a host cell to reproduce? So they have to take over the machinery so the host cell can make their proteins for their capsid cover. And so these interferons will help slow down protein synthesis, and so that will help slow viral reproduction. Okay, you can see that happening over here in the right. Okay, the interferon is preventing the virus from entering. It's trying to prevent the virus from leaving if it got in there, and it's slowing the protein synthesis down inside of the cell as well. Okay, these interferons also help our macrophages. Again, if you think back for a few minutes ago, macrophages are very large phagocytic cells. So they're going to, it's really important that those cells stay healthy when we're trying to fight an infection. And so these interferons help the macrophages resist getting a virus. They help the macrophage resist the virus entering them. Therefore, the macrophages are working at 100% to try to take care of your infected cells. So next we have our inflammatory response. So our inflammatory response is going to cause the release of histamine and prostaglandins. Histamine is going to it's the chemical that's basically going to cause most of these things. It's going to cause the increase in permeability of the capillaries. It's going to cause the capillaries to expand a little bit. The prostaglandins are going to help manage kind of the local response. Okay, the histamine is a little bit more systemic, so throughout the entire body. Okay, so some of the things that will happen with the inflammatory response when we release this histamine and we release these prostaglandins. Okay, so initially one of the things that we're going to do is we're going to attract more leukocytes, more lymphocytes, more phagocytes. We're going to attract basically more white blood cells to the area. Okay, well that would be important, right? I've got something bad going on, I need to get rid of it, so let's bring in the cells that can help do that. Okay, it's also going to make the capillaries more permeable. Okay, the benefit to making the capillaries more permeable is you can see these white blood cells here, or they're able to get through easier. It's going to release fluid, which will contain nutrients out into the area. That also, though, is going to cause swelling. So I'm going to get this increase in interstitial volume. So I'm going to cause swelling. Most of the time we associate with inflammation these symptoms down here on the bottom. The heat, the redness, the swelling, the tenderness, and the pain. Okay? Those things all go along with the inflammatory response, but this is what's causing them. The release of this histamine, okay, the increase in the interstitial volume because the capillaries are becoming more permeable, so that's going to cause the swelling. The increased blood flow to the area is going to cause the redness, cause the heat. If I've got the increase in swelling, that can make it more tender because everything is basically getting squished. So all of these signs down here at the bottom are all signs of inflammation, but they're signs of inflammation because these things at the top are happening. And our last non-specific defense here is a fever. So most of us know what a fever is, right? We're maintaining our body temperature at a point that's higher than normal. Okay? And our own body will cause this. We activate the leukocytes and the macrophages, and they'll release chemicals called pyrogens. Okay? Pyro's fire, right? Those pyrogens are going to impact our set body temperature. They'll actually elevate the set body temperature. You can see in the little diagram here that I definitely took from Texas Tech. Okay, is that we've got these pyrogens, and you've got pyrogens that are, you'll see here, you've got exogenous pyrogens, so the ones that are the bacteria, the viruses, the endotoxin. Okay, and then you have your own pyrogens in your own body that are trying to trying to make this environment inhospitable for the foreign invaders. Either way, they're going to impact the hypothalamus. The hypothalamus is what kind of sets our body temperature point. And so the hypothalamus, that body temperature will get raised. Instead of being set at, let's say, your average and your 98.7, now the hypothalamus is, you've changed the thermostat, and now you're saying, hey, our set temperature is 101 right now. Okay, and so that fever is trying, is a sign of your body trying to fight off an infection. But again, it is a non-specific defense. So our focus for the next few lessons, modules, whatever you want to call them, is going to be centered around these non-specific defenses.